Hello chemistry students, this is Mr. Nicholson, and today we are going to look at balancing chemical reactions. This is a core chemistry skill that many students, when they first start out learning chemistry, can find difficult. They can find it challenging, even puzzling, and sometimes even frustrating. So, let's start by asking ourselves, why? Why do we balance chemical equations? Why do chemistry teachers across the state torture their students by making them go through these steps of circular logic when it comes to balancing chemical reactions? Well, because it's important. As much as we would like, we cannot create or destroy matter. We can only change it. We can only change it, and what that really means is we can only rearrange it. We can only rearrange it on an atomic level where we're moving around electrons. And of course that can result in us making quite normal things stranger. But when it comes to it, what that lets us do is that lets us actually predict what's going to happen. That lets us predict the ratio in which chemicals react, and we can use that for fun and profit. We can use that to actually do things safely and avoid the horrors of face melting off. Okay, so today what we're going to be doing is we are going to be balancing chemical reactions using 3 different methods. I'm going to show you how to use each of these 3 different methods. 1, the atom symbol tally method. 2, table tally method. And 3, the way I do it, which I tend to think of as fast, nasty, and ugly. Okay, starting with the atom symbol tally method, we are going to demonstrate how to balance a chemical reaction. The reaction we are going to use is the reaction between nitrogen and hydrogen to form ammonia, which is known as the Haber process, and we will look into that in more detail in Year 12. Now, if we have a look at this, we start with a nitrogen, that's an N2 molecule. We have a hydrogen, H2 molecule, and we have ammonia, that's an old name for a chemical. It's not in any way a systematic name, and so that's NH3. So, what we're going to do right now is going to look at how we can balance this, and we're going to do this really simply. So starting on the left-hand side, we have nitrogen atoms. And we're just going to draw our symbols for our nitrogen atoms just here. Okay, it's because we have 2 nitrogen atoms, because we have the subscript just there. We have 2. Then, of course, we have to balance it. So we go from 2 to 1. That doesn't work. We're losing a nitrogen atom. That does not work at all. So let's make sure we balance our nitrogen atoms. By having 2 of these, we need to put a prefix out the front, timesing our ammonia molecule by 2. Now, what that means is that now we have 2 times 3 hydrogens. So we went from having, just in the molecule, 3 hydrogens, but now because we have 2 of these molecules, we now have 6. Alright, and so we have to circle this back into our hydrogen over here. And we only have the 2 to start with, but we need 6. So we need to have another 2 pairs of those. So we need to go from 2 to 6, and that's pretty simple. We just need to have 3 of those now, and now we have a balanced equation. And that is all there is to the steps of the atom symbol tally method. It's one of the most simple ways of doing it, and it's a really good starting point if you're struggling with balancing chemical equations. For our next example, we are going to look at a slightly different method to balance chemical reactions. We're going to use what I call the table tally method. And the example we're going to look at in this case is the decomposition of water to hydrogen and oxygen. In this case, it is often a reaction that happens when you use electricity to break down water into its components. And so in this chemical reaction, you have your H2O molecule, your water molecule, falling apart to hydrogen and oxygen molecules. But we can't have hydrogen atoms and oxygen atoms by themselves, which is an issue because if you have a look here, you've got 1 oxygen, and over here we have 2. It's not balanced. Let's fix that. So, starting with this tally method, just here, you write down the atoms that are present. Hydrogen, oxygen. Hydrogen, oxygen. And then what you do is you tally them. So you use a simple tally, just like sticks. And so we have 2 there and 1 there, followed by 2 here and 2 over here. And then what the goal is, of course, is to make it so we have the same number of atoms on each side of the chemical reaction. So here we have 2 hydrogens, 2 hydrogens. That's okay for now. All right, here we have 1 oxygen and 2 oxygen atoms over here. So we need to increase that. We need to increase that. And by increasing that, we are going to have to be putting a 2 out the front of there. Which by having a 2 out the front of there, we'll change something else. We'll change our number of hydrogens. We'll go from having 2 to 4. Okay. Now once we've done that, okay, we need to have a look at how that changes. Makes no changes to our oxygens, but it does change our number of hydrogens over here. Because we need to balance it out. All of a sudden we have 4, now we have 2. Doesn't work. So we need to have the same number on either side of the arrow. Okay, and which by having 4 over here, we need to have a 2 out the front of there. And there we go. Balanced. It's a very similar way to method 1, but if this works better for you, it's about using the right tool for the job. Alrighty, so for our third and final method of balancing chemical reactions, we are going to take a look at the combustion of methane. Now you might think of methane as being a smelly gas, but it's actually odorless. We make it smelly, so if we have a leak of natural gas, which is mostly methane, what happens is that we actually can smell it. And we make that smell foul, so we do something about it and don't explode and die. Now, for this method, it's actually pretty straightforward. It's another variation on the tally method, but you do most of the work in your head. You just have to have a few simple rules for about how you do it. And it works by working from left to right. And so if we have a look at this, and what I'll do is I just start just down below here. These are just temporary numbers. So we have 1 carbon atom. So go look here. I have 1 carbon atom on this side of the arrow here for our reaction with methane. And I have 1 carbon atom over here. So I'm going to start by going 1 and 1. So that's balanced currently. And then, once I have a look over here, I have 4 hydrogen atoms. Okay, so I'm just going to put a little comma in. Now I have 4. I have 4 hydrogen atoms. If I have a look over here, I have 2 hydrogens. I'll put a comma in for the oxygen, which I'll come back to. And that doesn't work. That doesn't work for me. I'm going from 4 to 2. I'm missing some hydrogen atoms. If I was a banker, I'd be really worried because I just lost 50% of my stock, 50% of my funds. I'm going to cross that out, and I'm going to make that into a 4. And by doing that, I have to put a 2 out the front of here. And have a look now. That's going to affect our oxygens. And so we'll pick that up. We'll pick up that change right now. Okay, so we have 2 times 1 for our 1 oxygen atom, which means we have our 2 oxygen atoms. Remember, we use the comma to separate them. And just going from left to right. Okay, so look at this. All right, we have 2 oxygen atoms here. We have comma 2 here, 2 oxygen atoms just there, and then we have 2 there. Well, that means on this side of the arrow over here, we actually have a total of 4 oxygen atoms and only 2 over here. That's a bit of a problem, isn't it? So over here, we need to times this by 2. So I'll cross that out. I need to make that a 4. And we do that by timesing our oxygen by 2. We have 2 oxygen molecules. And there we go. We now have a balanced chemical reaction. If you look at this closely, we have our 1 on each side. We have 4 hydrogen on each side, and now we have 4 oxygen atoms on each side. There we go. That's all there is to it. Now this third method, it is difficult, but it's one that comes with experience. So don't let it bother you if you struggle with this third method to start with. Use the right tool for the job. Now remember, you may be puzzled, but when it comes down to it, you just have to do it. You just have to practice. You have to get good at this. Alright, so right now, You have to choose the right way for you, and you might want to try and start on the fast, the nasty and the ugly way, but if that's not the right way for you, start on one of the tally ways. Get good at doing it, and then try out the other ways. It's just practice. You need to practice. You need to just do it. Thank you for watching. I'll make you all chemistry ninjas by the end of this, and I'll see you in class. Bye.